thick sections of rocks. So different types of basalts, and then some other minerals, and epoxy them to glass slides, and I'm going to sterilize them, stick them in this contraption, send them down to the bottom of the ocean and see what grows on them. So what I'm going to do today is just figure out how I want to configure everything, glue them in here, and start sterilizing them. This contraption has little slots drilled in it, so what's going to happen is we'll stick these inside, glue them in there, and then the borehole fluid will flow through here, and any microbes that might be in the borehole fluid will hopefully land on these and start growing. All these rocks, except for the green one, came from the Loihi seamount, which is the youngest Hawaiian seamount. So the Hawaiian island chain is growing on a hotspot, so the Loihi is what will be the next Hawaiian island in 100,000 years. And it's a place that is another hydrothermal system, and it's dominated by iron bacteria. The hydrothermal fluid has a lot of iron in it, but it doesn't have a lot of sulfur, which most hydrothermal systems have a lot of sulfur. So Loihi's different because it has more iron. So one of our labs of the research project is to study the organisms that grow there. So all these basalts came from that site. Katrina Edwards is the main PI, or one of the main PIs on the project. The project is called FEMO, which is the acronym for it. It stands for Iron Microbial Observatory. So it's one of the microbial observatories that's funded by the National Science Foundation. It's Katrina Edwards, Dave Emerson, Craig Moyer, Hubert Staudigal, and Brad Tebow are the main PIs on this project. And then the samples were collected with Jason, the remotely operated submersible that's run from Hui. And yeah, so whoever went down to the dives were elected that day. Grad students, PIs, whoever was there. That's an ongoing project. They're actually going there in October again. I'm going to miss that cruise. So these have inclusions of different minerals, like olivine, iron-rich minerals, in addition to the basalts, which are more silicates. So we're going to put different types of rocks down. This is almost a pure form of olivine, just to see how the colonization differs, whether organisms like having all these inclusions, they have different minerals to choose from, or if they like going onto basalts. I don't know how well you can see this, but this one has little air bubbles that show up when you polish the rock. So when the basalt forms, right, just like lava, right, it can have air bubbles trapped inside because it forms so quickly. So some research indicates that bacteria like to colonize those little pockets because they go anaerobic. So that's why we picked some of the rocks that have these little bubbles in them. And we also have some that are a little bit rougher than others. They're not as smoothly polished. They have little divots in them. At the seafloor, at the 1026 hole, this doesn't match. There we go. So a few days ago, there were osmo samplers recovered from the 1026 site. And when Jeff puts down the new set of osmo samplers in a few days, this contraption is going to be stuck inside one of those osmo samplers. So the fluid that's going to be passing over these rocks will be formation water coming up through the borehole and then venting out at the cork head. So as it vents out, some of the water will be sampled by the osmo and some of it will flow through here.